U telima živih bića kolagen igra veoma značajnu ulogu. Prepoznajemo ga u procesu starenja, zatim zarastanja rana, a takođe kolagen koji okružuje tumore ima značajan uticaj na to da li će neki tumori metastazirati ili neće. Dr. Rikardo Čiki iz Italijanskog instituta za optiku ovih dana bio u radnoj poseti Institutu za fiziku u Beogradu. Oni sarađuju na jednom twinning projektu koji se zove BioQuantSense, gde se uparuje iskustvo Srbije u kvantnim tehnologijama kao i italijansko poznavanje biofotonike i fotonike. Oni će zajedno nastaviti da rade na proučavanju kolagena, a potencijalne primene ovakvih projekata mogle bi da imaju snažan doprinos medicini.
I have a background in physics, especially in atomic physics and laser spectroscopy, but since the beginning of my career, I started working on biophysics and biophotonics because I was interested in the application of physics to biology and medicine. Now I'm a senior researcher and I am the head of the biomedical optics group. So my research team in Florence develops optical methods for non-invasive diagnostics of tissues, both at the histopathological level but also at the clinical level. So we are trying to target multiple problems from more fundamental characterization of tissues, and for targeting these we are using laser scanning microscopy with multiple contrast mechanism and nonlinear interaction of photons with the biological matter. And then for more clinical application, we used instead optical fiber probes and spectroscopy because these are more flexible solution and more suitable to be integrated within the surgical scenario and with the medical equipment. Some particular aspect I'm very interested in my career is the study of collagen, because most of our body, in terms of protein content, is made of collagen. And collagen plays a very important role in a lot of processes, from aging, tissue development, wound healing, but also it affects the environment of a tumor, so it determines if a tumor is going to metastasize or not. So the study of collagen in this organization is very important. So during my career, I always tried to study the organization of collagen using non-invasive methods, non-invasive optical methods, and try to characterize not only the morphology, but in recent years also the biomechanics of collagen, because the organization plays an important role, but also the mechanics plays an important role, because in tissue development you have always matching of mechanics between different compartments of the tissue. And so now we are trying to target to measure mechanical properties using optical non-contact methods. On the other hand, on clinical application, we implemented different spectroscopies within optical fiber probe to provide a more detailed characterization of tissues, and for analyzing data we implemented a neural network and artificial intelligence methods in a certain way similarly to face recognition approach. And more recently we developed setup for determining the tumor border to be used directly in the surgical scenario. So this is something like a pen, it's an optical fiber probe, and the surgeon can put on the tissue and determine the tumor borders by looking at the monitor where the, let's say, the characteristic, the autofluorescence characteristic of the tissue are represented as augmented reality on the screen. Potentially, it could be integrated in robot for surgical robots, or also within augmented reality glasses for surgery. Project is on bioquant sensor, so part of the project is on quantum biophotonics. So within this project, we want to merge the experience we have on biophotonics and biomedical optics in our group in Florence, together with the expertise on quantum technology here in the Institute of Physics in Belgrade, to merge the two technology and try to move quantum technologies to biophotonics, and then to translate, first of all, within the research laboratory, and then possibly also to transfer this technology to the biomedical scenario and also to the clinical scenario for benefiting all the community.